Doing a cracking the code interview question. This one is find the common ancestor. So you're given a binary tree. Um, doesn't have to be a binary search tree, but just any binary tree. This one kind of looks like a binary search tree, but 3 is greater than 5, so it's not binary. But the thing is, so you have a function that you take two nodes, just say 3 and 8. Like, what's the first common ancestor between these two nodes? That's what you want to figure out. So the answer would be 7. So it's like 8, or 8's the grandpa 3. So it's like, how about we're given 3 and 2? Would be 5. 10 and 4 would be 7. Kind of so on and so forth. Like 8 and 10 would be 9. Yeah, Mike, there's kind of two approaches to this. Is with your nodes, do they have a parent attribute? So on this node 9, are we privy to information that 7 is the parent of 9? In that case, it's just going back to 8 and 3, where nodes, you just keep on going up the tree, go up and up the parent until you crisscross at 7. So like 4 and 8. I think you also determine too if you want to use height, if you know height of each level. So this would be level 1, height 2, height 3, so on and so forth. But yeah, so then you just keep going up until you crisscross. So you can create 8 or 9, 7, and then keep going up, and 2, 5, 7, but 7's already been traversed, so then you say 7. The way I'm going to show it, or other ways when you don't know those two, but you're given the root of the tree, and you're given 2 nodes. So your function will take in the root, and then it'll take in 2 nodes, node 1 and node 2. So, and kind of like key insight here is, so yeah, so that's kind of like the prior versions, like working bottom up. This is like top down. You start at the top, and then the key insight though is the node, the common ancestor is when one of the nodes is in the left subtree and one is in the right. So like in this case, it's 7, or like 8 and 3. 3 is in the left and 8's in the right. But let's just say we want to find the child or the common ancestor between 4 and 3. If we start at 7, both of these nodes are in the left hand, so that means we're going to recurse and call root on this a node. So then now we check 3's in the right and 4's in the left, and then that's good. So 5 is the common ancestor. Yeah, so it's kind of it's a recursive start at the root and recurse down until you find the common ancestor, where the common ancestor is one of the nodes is in the right and one of them is on the left. So to get to the code, this is in Python. So you have your main function common ancestor, takes in the root, node 1, node 2, and then we're going to use an ancestor helper. That's actually going to be the recursive function. And then we have this third function called covers, and all covers does is it takes a root of a subtree or a tree and a node and checks if that node is within that tree. So yeah. So the first case here in line 67, make sure all this does is just to make sure the both nodes exist in the subtree, right? So is n1 in the tree when the root is 2 into the root. If any of those equal false, then we turn down and saying, hey, these nodes aren't in the subtree. Other than that, we get to the meat of the problem where we call this ancestor helper function. It also takes the root and the 2 nodes. And here it's just the edge cases if you have an empty tree, or if the root that you're searching on is one of the nodes, then you just return that root. And that's the common greatest ancestor, which is kind of weird. So if you're given 8 and 9, the common ancestor is 9, and that's 7, which is kind of weird. But yeah, nonetheless, it would be 9 in that answer. So, but yeah, so here we go. Now we got to figure out kind of the key insight, the meat and potatoes of this is you have two functions or two variables or methods that return the Boolean, which returns a Boolean. You want to say, hey, is node 1 in the left? So this variable will have true or false being is node 1 in the left subtree, and is node 2 in the left subtree. So these are either going to be both true, both false, or one true, both false. And what we want is one of them to be true and one of them to be false, because that's line 81. So if one of them is true, one of them is false, so they don't equal, that means we found that's the common ancestor, and that's what we're looking for. So we return it. But if we don't, we move on to line 83. Then we got to find what side did we search. What side was the two nodes on? Were they on the left-hand side or were they on the right-hand side? So, so side to search, that will be either a node left or right, which it kind of boils down to. And then this part here is just a ternary function in Python. So if it's on the left, if both of them are on the left, then return the left. Else just go to the right, so both of these would be false. And then, yeah, you need just recursion. You call ancestor help again with the side to search, if it's left or right, and then the two nodes that you're still looking for. And that's pretty much it. Yeah, covers just use the helper function. It's also a recursive helper method that finds if a node's in the root or in a tree. But yeah, the time complexity of this is the worst case scenario is we have to hit every node, so it's linear. So have to hit every node, it'll be linear, and then space is constant time since we're not building up any others auxiliary or supportive data structures. So actually, since it's recursive, we'll build up a recursive stack. So that'll not be good. If we might have this iterative way, you can do a while loop. But yeah, nonetheless, space is kind of cheap, but the time complexity is linear. So yeah, that's pretty much it. And then yeah, so we can run it here a little bit. I built up this tree right here. I built it with these nodes here, so I instantiated all the nodes, and then I declared their left and right childs. So so in this case, let's look for node 3 and 4. So 3 and 4, its parent child will be 5. So if we do that, it returns 5. So let's look for, how about 2 and 10, which should be 7. So let's look for node 2, node 10, and that's 7. And let's just do a right-hand side. Let's do 8 and 10. 8 to 10 should be 9. This should be 9, which it is. And let's just do 11 and 10. I think this should, I don't think I tested this one. Which should return 11. Yeah. So there you go. That's how you find that the common ancestor in a binary tree.